Today we are going to be reviewing how to solve two-step inequalities, but mainly later on how to write and solve inequalities. So first we are going to solve each inequality, and then we're going to graph the solution on the number line. So remember, when solving inequalities, it's very similar to solving equations. The only difference is we have to remember, okay, when we multiply or divide by a negative, you must flip the inequality. Okay, so for example, if it's a less than or a greater than sign, it's going to become a less than sign. Or if it's a greater than or equal to, it's going to become a less than or equal to, and vice versa. Okay, that can go either way. So if it's a less than, it'll go to a greater than, or a less than or equal to, it's going to go to a greater than or equal to. That's the main thing we just have to remember. Okay, if not, all the steps are the same pretty much. Okay, so first, number one, we have x divided by 2 minus 1 is less than 5. So my first step is where we do the inverse operation. I'm going to locate the side of the variable, the x divided by 2 minus 1, and we need to get rid of the number that does not have a variable with it. So the minus 1 does not have a variable with it. Okay, so to get rid of the minus 1, we're going to add 1 to each side. Remember, your work should look exactly like mine. If you don't have plus 1 under the minus 1 and plus 1 under the 5, you do not get the point. Okay? So now that leads us to our result once we, simplify this. So the minus 1 plus 1, they cancel out. Okay? That gives us 0. So that brings us the x divided by 2 down is less than 5 plus 1 is 6. Okay? And so how I got that was the 5 right here plus 1 equals 6. So we're not done because the variable is not by itself. Just like equations, the whole goal is to get the variable isolated. Okay? Get the variable isolated. So now we need another step. This is x divided by 2. This is the side with the variable, so I'm going to focus on it. To get rid of divide by 2, the inverse operation of dividing is multiplying by the number 2. So I'm going to multiply each side by 2. So I multiplied by a positive number. So my sign stays the same. I only change it if I multiply or divide by a negative number. So I multiplied by a positive number. So I don't have to change my sign. My sign's still going to be a less than sign. So the 2's cancel out and leave me with the x is less than 6 times 2 is 12. Okay. So for my check, remember, with inequalities, that's the other thing that's a little bit different than equations. With inequality, there's many answers we can plug in for x that make that statement true. Okay, for inequalities, we have more than one answer. So when we check it, we use a number line. Okay, my variables on the left side, that's one thing we always want, variable on left side of the inequality. Okay, so now we know x has to be less than 12. So I have a less than, so that's going to be an open circle on the number 12. Since the variable is on the left-hand side, we can use our little trick. I'm going to rewrite the inequality sign I have, which is a less than, and I'm going to make it into an arrow, and it points to the direction it wants me to shade. Okay? Or if we read this inequality, we need to shade everything less than 12. Okay? Well, 11 is less than 12, so it's going to be shaded. 10 is less than 12, it's going to be shaded. So anything less than 12, it's going to be shaded. Okay? Remember, if you ever need to know if you shaded the right way with your answer, input, substitute that number in. So if I substituted 11 and for the x, 11 is less than 12. That's true. Okay, so 11 is less than 12. That's true. So it should be shaded. Okay. Number 2. We have 13 is greater than or equal to negative x plus 7. Okay, so for our step, the side with the variable is negative x plus 7. So we need to get rid of that plus 7. Okay, so we're going to subtract 7 from each side of the inequality. So for our result, we get 13 minus 7 is 6 is greater than or equal to, the 7's cancel out and leave us with the negative x. Okay, remember, when our variable is isolated, it has to be a positive. So here, this is a negative 1x. Okay, this is a negative 1x. So for our next step, we need to divide each side by negative 1, because this is negative 1 times x. So the inverse operation is dividing by a negative 1. Okay, guys, we divided by a negative number. Okay, so when we multiply or divide by a negative, we must flip the inequality. So here we have a greater than or equal to. So now it's going to change to less than or equal to. 6 divided by negative 1 is negative 6. Negative 1 divided by negative 1 cancels out to give us that positive x. Okay? So our variable is not on the left-hand side. So I'm going to keep that as my answer because that is correct. But to check it with graphing the number on the number line, I need to make it so my variable is on the left-hand side. So remember, guys, how we do this is our number is negative 6, our variable is x. So I'm going to go over here. I'm going to rewrite x on the left side and negative 6 on the right side. So now I look at my inequality symbol. Okay, it's pointing to the negative 6 and opening up towards the x. So when I rewrite it, it still has to have those same features. So it's going to point to the negative 6 and open up to the x. So negative 6 is less than or equal to x is the same thing as x is greater than or equal to negative 6. Okay. Once again, I highly recommend you keep the answer what you get it and then go off to the side. Don't erase it and put what you get just in case you make a mistake, This is the right answer. So if you have this, you also get a point. Okay. So now, when we shade, this is going to be a closed circle because it's greater than or equal to on negative 6. So on negative 6, I'm going to have a closed circle. Since my variable is now on the left-hand side, I'm going to rewrite the inequality, and then I'm going to make it into an arrow, and it points in the direction that needs to be shaded. Okay? Remember, when the variable's on the left-hand side, if it's greater than, you shade to the right. If it's less than, you shade to the left. Okay, you can also remember it by that. And once again, you can always check by taking one of these numbers that are shaded in and putting it into your inequality answer. Okay, if it's true, then you know you shaded it in the right direction. 3. we have negative 2 plus 3x is greater than negative 23. So negative 2 plus 3x is greater than negative 23. So the side with the variable is negative 2 plus 3x. So we need to get rid of the number that is not being multiplied or divided by the variable. So the constant of this is negative 2. So for my first step, since this is a negative 2, I'm going to add 2 to both sides of the inequality. That's going to give us the result. The 2's cancel out, leave us with a 3x is greater than negative 23 plus 2 is negative 21. Okay, so we're not done. The variable is not isolated. So this is 3 times x. Okay, so the inverse operational multiplication is dividing the number in front of the variable, so the coefficient is 3. So I divide each side by 3. In my step, I divided each side by a positive number, so I don't have to flip the inequality sign. Okay, so it's still going to be a greater than. So the 3's cancel out and leave us a positive x. Negative 21 divided by 3 is negative 7. Okay, so remember, you only flip the sign if your step is multiplying or dividing by a negative. Okay, we divided by a positive 3. So now I need to shade the variables on the left-hand side, which is great, so I don't need to do that extra step of changing it. I need to shade everything greater than negative 7. So it's going to be an open circle in the negative 7. Greater than means shade to the right, or if we want to use our little trick, since our variable's on the left, I rewrite the inequality symbol, okay, and I make it into an arrow, and it points the direction I need to shade. And number 4, we have 3x minus 4 is less than or equal to 23. So our first thing is to locate the side with the variable. So the 3x minus 4, we need to get rid of this minus 4 because it's a constant. So for our step, we're going to add 4 to each side. That's going to give us the result. The 4's cancel out and leave us with a 3x is less than or equal to 23 plus 4 is 27. We're not done. The variable is not by itself. We have 3 times x is less than or equal to 27. Well, 3 times x. We need to get rid of that 3. Okay? So it's being multiplied. Okay? The x and the 3 are being multiplied. So to get rid of multiplication, we have to divide each side by the number or the coefficient of the variable. So divide each side by 3. Okay? So the 3's cancel out and leave us with a positive x. We're dividing by a positive number, so we don't need to change the sign. 27 divided by 3 is 9. So our variable's on the left-hand side, so we're good. We don't need to flip it. So it's a less than or equal to, so it's going to be a closed circle on 9. It's less than, so I should be shading to the left. Once again, if I rewrote the inequality symbol and made it into an arrow, it's telling me to shade towards the left. Okay, I highly recommend at this point, stopping the video. If you need to review these 4 questions again, please rewatch it. Okay, so now we're going to really focus on writing and solving solving inequalities. Okay, once again, writing and solving inequalities are very similar to writing and solving equations. There's just a couple differences. Okay, instead of equal signs, we're now going to be having inequality signs everywhere. Okay, so let's work through the first problem. Grace earns $7 for each car she washes. She always saves $25 of her weekly earnings. This week, she wants to have at least $65 in spending money. At least how many cars must she wash? Write an inequality and solve. So, just like equations, we still have to define our variable, okay? Defining our variable is what we're looking for. We're looking for at least how many cars can she wash, okay? So, when we define our variable, once again, we're in inequality, so we should not have any equal signs. So, okay, our inequality, or our variable is going to be x. At least, okay, if you went over, at least is greater than or equal to, okay, because think about it, if you want at least $5, okay, if you want at least a certain amount, the minimum you want is whatever, but you could get more, you can have more, okay, so x is greater than or equal to, and then how many cars must she wash? So number of cars. Okay, so the inequality we have here, that's going to go straight down into the next line for when we actually have to write our inequality. Okay. So at least represents greater than or equal to. Okay, so just like equations, okay, the total will go on the right hand side, everything else will go on the left. So we're talking about how much she earns for washing cars, how much she always saves, and how much she wants in spending money. So we know $7 for each car. She saves $25 of her weekly earnings. And then she wants to have at least $65 in spending money. Okay, so at least $65. So that is considered to be at least. 65 is the total amount of spending money she wants to have. Okay, so that's going to be my total for this situation. Okay, so we dealt with the $65. We need $7 for each car. Well, think, our variable deals with the number of cars. So the 7 is going to go with our variable, because our variable deals with the number of cars. Okay, so 7 for each. Guys, each means multiply. So it's going to be 7 times the number of cars, so times x. And she always saves $25 of her weekly earnings. So if she saves $25, we're going to add 25 to that, because the amount of money she makes with the cars plus the amount she saves for the week should be at least $65. Okay, so now we have wrote our inequality. Now let's solve it. Okay, so we have 7x plus 25 is greater than or equal to 65. Okay, so the side with the variable is 7x plus 25. Our step, we need to get rid of the constant, or the number without the variable, so the plus 25. So we're going to subtract 25 on both sides. Remember, if yours does not look exactly like mine, you will not get the point. Just like equations, each line is a point. It needs to look exactly like mine. Right under the numbers, the minus 25 should be right under plus 25. The minus 25 should be under the 65 on the right-hand side, okay? The 25s cancel out and leaves us with the 7x is greater than or equal to 65 minus 25. 65 minus 25 is 40. we're not done. The variable is not isolated. So this is 7 times x. Okay, we're at the step, so we're doing the inverse operation. The 7x is being multiplied. So the inverse of multiplication, inverse operation, is dividing. The coefficient, or the number in front of the variable, is what we're dividing by. So we divide each side by 7. Okay, we're dividing by a positive number. Okay, so we don't have to change the inequality. So that's going to be greater than or equal to. The 7's cancel out and give us a positive x. 40 divided by 7 is 5.7142857. Well, let's think about this, guys. Okay, let's think about this. Can you, if you're washing a car, can you wash 5.7 of it, like a 7th of a car? No. Okay, you would have to round up. Okay, so washing just 5 isn't enough. So with actual objects, sometimes you'll have to round up. So you would have to wash a total of 6 cars. Okay. So once again, let's just kind of walk through that, why I rounded up to 6. The reason I rounded up to 6 is because 40 divided by 7 is 5.7. You would not think, if you went to a car wash and you were that 5th car and they didn't pretty much, didn't finish washing the car all the way, you would be upset. So you'd have to round up. Okay, so that's the reason why we rounded up. So now I have to make my number line. The number I got will go right in the middle. You need to go 1 above, which is 7, and 1 below, which is 5. So x has to be greater than or equal to 6. So it's going to be a closed circle on 6. My variable is on the left-hand side. Always try to write your inequality so the variable is on the left-hand side. So I need to shade everything greater than or equal to 6. So greater than is to the right, or if I rewrite my symbol, make it into an arrow, it points to the direction I need to shade. Okay, flip to the back. We're going to do 2 more problems together, okay? So, Monty has saved $400 to spend on a video game player and games. The player he wants cost $275. The games each cost $39. At most, how many games can he buy along with the player? Write an inequality and solve. So first, let's define the variable. Once again, we're in inequalities, so I should always have an inequality everywhere. So our inequality is going to be dealing with the at most. Okay, at most is less than or equal to. Okay, think about it. That's like a maximum. The at most, I always try to think of it in a smaller scenario. So with money, if I want my, parent or guardian to at most give me $10, well, $10 is like the max amount, okay? Or anything less than that as well. So it's less than or equal to. So my variable is x. So x has to be less than or equal to, we're looking for how many games he can buy along with each player. So, number of games. So now let's work on writing the inequality. Once again, my inequality symbol is going to be the less than or equal to. So we know Monty has saved $400 to spend on video games and player and games. The player he wants costs $275. The games each cost $39. Okay, so let's think about it. You have how much he's completely saved, the cost of the player he wants, and then how much each game costs. So our total in this situation is how much he saved. Because think about it, the cost of the player plus the cost of each game he wants, add that together, it has to be less than or equal to the amount that he saved. Okay, so 400 is going to go on the right hand side. The player he wants is $275. So 275. The games each cost. Okay, each means multiply. So we're dealing with the games and the cost of each one. Okay, so that's going to go with our variable, number of games and how much they cost. Okay, so we're going to add 39 times x. Okay, so this is our inequality. If you have 39x plus 275, that is also fine as well. Okay, I just like to write it how I read it, and so this is how I'm going to have it written down. So now it's time to solve. Okay, we have 275 plus 39x. That is less than or equal to 400. So this is the side with the variable. Get rid of the number that is a constant. It doesn't have a variable. So the positive 275. So to get rid of this positive 275, we have to subtract 275 on both sides. That cancels out the 275. The 39x comes down. Less than or equal to 400 minus 275 is 125. Okay, so for our step, okay, the variable is not by itself. This is 39 times x. Okay, so the inverse of multiplication is dividing each side by the number in front of the variable or the coefficient. So divide each side by 39. 125 divided by 39 is 3.205. Okay, well think about it. We're seeing the 39's, we didn't divide by a negative, so we keep the same sign. Less than or equal to, the 39's cancel out and leave us with x. 125 divided by 39 is 3.2. Okay, so let's think about this. Okay, 3.2. We're dealing with buying video games. You're not going to buy 3.2 of a video game. Okay, you can't round up to 4 because you don't have enough money for 4. Okay, so we have to round down in this scenario. So x has to be less than or equal to 3. Okay, one thing that I did not do on the last problem that I need to go back and do after this is don't forget to label your answer. Okay, x is less than or equal to 3 what? Well, 3 games. Okay, so let's finish off with the check. So 3 is going to be the number in the middle. We go 1 above, which is 4, 1 below, which is 2. This is going to be a closed circle because it's in less than or equal to. And I need everything less than 3. So think, he could buy 2 games, he could buy 1 game, or he could buy no games. Okay. So, or the variables on the left-hand side, if you redraw the inequality symbol, make an arrow, it shows which way to shade. So before I move on, I want us all to look back at the first problem we did. Okay, where its x is greater than or equal to 6, okay, the number of cars, so it would be 6 cars, okay? Don't forget to label. Now, what I want you to do is try number 4 by yourself, okay? So pause the video at this time and try number 4. Okay, so now I'm going to walk through number 4 with you. Cooper Middle School has a goal of collecting more than 1,000 cans of food in a food drive. So far, 375 cans have been collected. During the last 13 days of the drive, at least how many cans must be collected each day in order to meet the goal? So we're looking at least how many cans must be collected each day in order to get the goal. So first we're going to define the variable, okay? So at least means greater than or equal to. So greater than or equal to. And the variable is going to be x, okay? And what are we looking for? How many cans must be collected? So number of cans. Okay, so now I'm going to rewrite that inequality symbol, greater than or equal to. So Cooper Middle School has a goal of collecting more than 1,000 cans of food. Okay, so the goal would be 1,000. Okay, so far 375 cans have been collected during the last 13 days of the drive. At least how many cans must be collected? Okay, so 1,000 would be our total. That's the total amount they want collected. So far, 375 cans have been collected. Okay, so 375 have already been collected. Now, during the last 13 days of the drive, at least how many cans must be collected each day? Okay, so we have 13 days to collect cans. So of the days, number of cans, this is really each day. Okay, so we're multiplying the days and the amount of cans. Okay, so here's our inequality. 375 plus 13x is greater than or equal to 1,000. So now let's solve. So we have 375 plus 13x. We need to get rid of the plus 375 or the positive 375, so we're going to subtract 375 on each side. That cancels out and leave us 0, so that leaves us with the 13x is greater than or equal to 1,000 minus 375 gives us a total of 625. So now, 13 times x. Our next step is we need to get rid of the 13 on each side. So this is being multiplied, so I know I'm going to divide on each side by the coefficient or the number in front of the variable. So I divide each side by 13. The 13's cancel out and leave us with x is greater than or equal to 625 divided by 13 is 48.076. Okay, so about rounding again. Okay, so we need just a little above. Once again, you can't bring 48.076 of a can. Okay, you'd have to round up. Okay, you'd round up. So this is an instant where if you round down, you don't meet the goal, okay? You have to round up. So it's going to be 49 and then cans. So each day they have to bring at least 49 cans to reach that goal, okay? So now I'm going to do my check. So 49 is going to go in the middle. One above is 50. One below is 48. So it's going to be a closed circle on 48. My variable is on the left-hand side. So I need everything greater than 49. So greater is to the right. If I rewrite the inequality symbol and make it into an arrow, it points to the right. If you have any questions whatsoever on how to write and solve inequalities, please contact your teacher. Remember, this is your homework for today, and it should be, sorry, scratch that. This is not your homework for today. You still have an assignment to do for homework today. If you have any questions over that as well, please contact your teacher. So once again, this was notes for the day. You do have a separate homework assignment, okay? So make sure you do that homework assignment, and if you have any questions over that, please make sure you contact your teacher.